Hello, ladies and gentlemen, and welcome back to more of our Alberta Math Contest. This is part one from 2017, and we're up to question number 9. Let x, y, and z be any real numbers that satisfies, looks like we got a pair of inequalities here. 3x plus y plus 2z is greater than or equal to 3. 2y minus x plus 4z is greater than or equal to 5. Okay, and we want to know the minimum possible value of 7x plus 5y plus 10z. Okay, so minimum possible value, and we've got some options here. But for 7x, 5y, and 10z, to find a minimum possible value, we'd be able to say, oh, well, there's this m out there that this is greater than or equal to. And when we realize that, and we say, oh, I've got some other inequalities. It was 3x plus y plus 2z. And that was at least 3, and the other one was at least 4? At least 5. And then I'm just going to rearrange it. I'm going to say minus x plus 2y plus 4z greater than or equal to 5 here. Okay. So what we'd like to be able to do is maybe use these two to create this inequality. Now, how can we do that? Well, just like when we solve systems, we can add equations. You can add inequalities together. So if I multiply that first inequality by, let's say, a, get 3ax plus ay plus 2az is greater than or equal to 3a. And this second one here, we could say multiply it by b, so minus bx plus 2by plus 4bz greater than or equal to 5b. And if I add them, you can still add on both sides. So we'll get 3a minus bx, but now I'd want 3a minus b to be equal to 7. And then we'd get a plus 2by, well, I'd want that to be 5. And then 2a plus 4b, I would need that to be equal to 10, and then we'd have this greater than or equal to 3a plus 5b. Now, one thing that tells me we're probably on the right track, if this is 5, look at what happens when you double it. You get 2a plus 4b, and doubling 5 would be 10, which is great. So what do I need? I need to find 3a minus b equal to 7, a plus 2b to be equal to 5. If I can find an a and a b that do that, then we're great. Okay? Now you can try and play around with it if you want. 3 times 3 minus a 2, but then 3 plus 2 times 2 is 7, so that wouldn't quite work. You can certainly try and play around with it if you want, but it's always a better idea to sort of take these expressions and have sort of something planned for what it is you're going to do. Okay? So for example, I might say, well, I've got 3 a's up here. What happens if I multiply this bottom equation by 3? You'll get 3a plus 6b is 15, and now if you take the top equation and subtract the bottom equation, suddenly you have no a's. You'll have minus 7b's is 7 minus 15, so negative 8. So b will have to be 8 sevenths, and now I could take that and I could plug it back in. Say 3a minus 8 sevenths needs to be equal to 7, just taking it and putting it in the first equation. So 3a is 7 plus 8 sevenths, that's 49 sevenths plus 8 sevenths. And so that would be 57 sevenths, and divide by 3. 57 divides evenly into 3, so that'll be 19. So a is 19 sevenths, b is 8 sevenths. Okay. If you wanted to, you could grab a calculator just to double check that. But I think we're good as is. And so now, what do we need? Well, m, the smallest these can be, would be 3a plus 5b. So 3a plus 5b. So that'll be 57 sevenths plus 40 sevenths. So we're looking at 97 sevenths, and you can't really divide 7 in there. But that should be our answer. Now, of course, the question is, can we find an X, Y, and a Z that do this? And we should be able to. But you'll notice our answer here, B, our answer is present. And you could tell we were on the right track with all those 7s because most of these divide through by 7. And this one here is just 98 over 7. But something you could do is you could try and find values of X, Y, and Z to make sure that you actually reach these minimums. It's certainly possible or certainly doable. I suppose I'll spend a little time trying to actually show that the minimum can be achieved, but we have answered our question. Oops. At this point, we do know the answer should be B, but let's make sure. Let's find an X and a Y and a Z that work. Now I'm going to let Z be 0 because we don't really need the Z in here. Because, well, you could just rename Y plus 2Z W, and you'd have 3x plus W needs to be greater than or equal to 3. And over here you'd have minus x plus 2W needs to be greater than or equal to 5. So you don't actually need the Z's here. So we're just going to use Y. So 3x plus Y needs to be actually equal to 3. Show that this minimum can be achieved. And minus x plus 2y needs to be equal to 5. Show that the minimum can be achieved. So again, we're just going to sort of come along, multiply by 3. This time we're going to add the equations. And we'll get 7y is equal to 18. So y being 18 over 7. And then x would have to be, so 18 over 7 plus 3 over 7 would be equal to 3, so it should be 1 over 7. Yeah, and that'll work out. So these minimums can be achieved, so this really is the correct answer. But we knew that a while ago. It was B. And we can, I guess, move right along to question number 10, and we'll take a look at that in the following video. Take care, and have a wonderful day.